Okay, welcome back to the AWS Developer Workshop Theatre here at Web Summit 2018. If you're watching us on Twitch, welcome back on Twitch. If you're in the room, who likes interactive demos? Good. If you didn't put your hand up, I'm going to make you do an interactive demo anyway, so you're going to have to participate in this. Later in the session, for this, you'll need the essential accessory of modern life, the smartphone. Has anyone here not got a smartphone? Good, okay. So I'm looking for 100% participation in the demo then, okay? Good. Right, so this is a session about using AI technology to change the way in which we interact with customers in the customer service context. And really it's about conversational interfaces. It's about enabling us to go to the digital locations where our customers hang out, where they are already present, and take service experiences to them that allow them to interact with our services using natural language, either type natural language in the form of conversational chatbots, or special purpose voice-activated chatbots, where you can literally enable customers to speak to your applications or speak to your devices, understand their intents, and fulfill those intents using back-end software. Okay, so that's what we're going to be covering in this session. And there's three areas that we're going to be talking about. The first is why conversational interfaces are such a hot topic right now. Secondly, how can the cloud play a role in helping you build these kinds of systems? What is it that cloud computing brings that makes it a really good place to build applications of this type? And then thirdly, we're going to dispense with slides for the majority of this session, and I'm going to show you how to get started with these services directly in the AWS console. So we'll provision a template conversational interface for supporting transactions in the travel industry, which is a prepackaged template that we have available. And then secondly, we'll jump into something which is custom built, and we'll talk in a little bit more depth about how to interact with our service, Amazon Lex, in a programmatic way. And you'll all have the opportunity to interact with one of these systems live during the session. If you're on the stream, you'll be able to do the same. So let's get going. Why are conversational interfaces such a hot topic? Well, this is all about making applications and software more accessible to the customers that we want to enable to use it. If you remember the early days of computing, there wasn't really a user interface. Access to the machine was controlled by a group of wizards. These would be your mainframe or systems operators. You would either write out your code, literally write out your code longhand and have them implement it into the machine for you, or maybe you'd be lucky enough to have a box of punch cards that you would punch, bring along, hand over to the operators and receive some punch cards back or some printed paper back, which had the results of your job either stamped in it or printed on it. This was generation one. We then moved on to computer interfaces which use analogs. They use folders and files and radio buttons and sliders and a mouse and pointer, of course. And this enables us to, in turn, enable a less sophisticated class of users to interact with applications and use information systems. There's a whole field here called Skeuomorphism, which is about taking everyday objects and transporting them into the digital world so that applications are immediately familiar to those people that you want to enable them to use them. The best example would be like iPad applications for note-taking that have fake spiral binders down the side of them and stuff like that. It's about engendering familiarity with the application, but we still need to know how to use the system at its core, right? And now we're on the third generation, which is I just type or say what I want, and there's an intermediary layer in the system that is able to understand what my intent is, extract the important entities from the utterance or the spoken word, and get back to me with an answer or get back to me with a request for further information, kind of naturally guiding me through the interface in a way which is conversational, hence the name conversational interfaces. They're natural to use. They require no training. They should be self-documenting or guide the user through the experience in a dynamic way so that we don't need to train or even familiarize our customers or users with what our applications require in order for them to be used effectively. Of course, they're in the locations where our customers are present. In the case of special purpose devices like the Amazon Echo, they're in the home or in the car, depending on what kind of device you're using. In the case of purpose-built chatbot interfaces, they might be present on social networks where our customers are already active, like Facebook Messenger or Slack or Twitter direct messages, so we can take our interface to our customers through an existing channel. Or they might be integrated directly into physical products or into other applications. Maybe touch a button on your cooker and say, cook this item for 30 minutes at 180 degrees. And then your cooker will inform you temperature has been reached. When the right temperature has been reached, you put your item in, that starts a timer, and you have a voice-activated timer system to make the process of cooking food more accurate and more reliable. Okay, so that's the kind of physical product integration that you can do with these kinds of interfaces. So what kind of role does the cloud play in helping you build these conversational interfaces? Well, the simple answer to that is we have a service called Amazon Lex that enables you to quickly and easily build, deploy, and scale conversational chatbots. And it covers quite a few pain points that are present in this type of application development, this type of domain-specific development. So I'm going to jump into the console and show you a little bit of the developer experience. Okay, so I'm in the AWS console here, and I'm operating in the EU Ireland region, which you can see up here is designated in this drop-down. At the moment, this service is available in these 3 regions. And the service that I'm looking at here, of course, is Amazon Lex. And in common with pretty much every other AWS service, if I don't already have a service instance for this particular service present in the region that I've selected, I'll receive this first run experience, which is a page which is intended to guide new users through using a service that they might not have interacted with before. And that's exactly what I'm going to do here, is show you the first run experience for a brand new developer that is getting started with this service. So obviously the first thing that I'm going to do is click this Getting Started guide button that you can see here. And that will open up 4 options for me, either to create a custom bot with my own custom logic, or to provision one of our sample applications. And the 3 sample applications that we have here are travel booking, ordering flowers, and scheduling appointments. Okay, so we've got different conversational or language models behind each of these different samples. And if I scroll this window down a little bit, you'll see an indication of what the conversational flow is for this travel-centered use case, for this book trip use case. I'd like to book a hotel. Sure. Which city? New York City. What date do you want to check in? Etc. So we've got this natural back and forth that will enable us to collect the information that is required to fulfill this intent by completing a booking transaction with a back-end booking system. That's essentially what we're doing with the conversational interface in this case. So I'm going to provision that into my account. And I'm going to provision that just by accepting the sample template and hitting create here. And this will just take a few seconds to provision the language model into my AWS account and make this available for testing directly within the console. Okay, so I'm not at this stage connecting a channel to this conversational bot. I'm establishing it for test purposes directly within the AWS console. There's another step that I need to go through in order to make this bot available on, say, a social network. But at this stage, it gives me the ability to test and experiment with the language model and demonstrate a few more features of the developer experience for you. Directly in the console here, you should be able to see a few different things. So we've provisioned that. The first thing is sample utterances. So these are the training data that is used to prime a classification model for intent resolution, to figure out which of the intents that are supported by my bot I am activating in response to a particular utterance that I will provide. Okay? And you can see there are actually 2 intents available in this sample bot: book a car or book a hotel. And we've got different sample data for those 2 intents. If I jump over onto the hotel intent, you will see that I have sample utterances that relate to hotel bookings. I also have a sample utterance here that has further entities, or slots as we call them within Amazon Lex, embedded within the sample intent. This allows me to do single shot intent resolution and entity extraction or slot resolution in one hit. So I can say, book a 2-night stay in London, and the values of duration and location will be populated at the end of the intent resolution phase in a single shot pass. Okay? So in order to build a model, I need to train or provide training data which are representative sample utterances that will enable the neural network classifier model to determine which intent I've triggered with a particular utterance. Okay? And then I have slots. I'm going to put this away so we can see a bit more of this slot information. The slots are the attributes that are required in order for me to fulfill the intent, in order for me to execute the transaction that is represented by this intent. So in the case of car hire, it's a pickup city, a pickup date, a return date, the driver's age, and the type of the vehicle. Okay? So if I experiment now in interacting with this sample chatbot, I can say something here like, book a car. Let's try something different, actually. Okay, so the first thing to point out is I said rent a car, and rent a car is not in my sample utterances. So I'm not matching here, okay? I'm using a probability-based classification model. Out of the intents that are available to me, book a hotel or book a car, rent a car as an utterance is substantially more likely to be resolved to book a car than it is to rent a hotel. Quite obviously, right? But what it demonstrates is that it's not matching those utterances. It is training a model that is then used for resolution, okay? And you'll see in which city do we want to rent a car. So let's say Lisbon. Okay, and you can see in the debug console down here, as I am specifying these slots, the values of the slots are reflected inside the state model that is maintained for my particular session. So I can use that for debugging. And I'm now asked, what day do I want to start my rental? And I can do something here which is obviously stupid. I can say like last Monday, okay? And you'll see that that resolves down to an ISO date here at the bottom. So that's one thing that I'll talk about in a second. But the second thing is, it's obviously nonsensical for me to rent a vehicle in the past, right? I can't make a reservation for a date that's already happened. So you should realize here that at this stage, there's no validation, okay? What's happening is I am detecting whether the data types match the data types that are specified in my slots. But I'm not able to apply any constraints, any boundaries, or validate whether or not the values that I'm providing actually make sense in the business context for this particular transaction. Okay, but we will identify that that's a date. The second thing to talk about, of course, is it's natural language here, but down here, it's a system representation of the date. So we have sophisticated language models here that are able to resolve down natural language dates and times into their relative dates given the current date and the calendar. So I could say Christmas Day, for example, or last Christmas Day, and I would get the 25th of December on the respective year. It's a sophisticated language model by virtue of the fact that we're using this built-in capability here, the Amazon date built-in, which is a pre-trained classification model and extraction model for date type data. Okay, lots of features in the platform for that. So we've demonstrated there that that doesn't actually work too well because we don't have validation, but let's continue. Let's return the car on next Friday, let's say, and that should give us a date in the future, of course, which it does. How old is the driver? They're 3 years of age. Again, we probably wouldn't want to rent a car to a toddler, but you can do that because there's no validation. And then we can specify what type of vehicle we want luxury. Okay? And then we have a confirmation step, and we can say in this case, no, we don't want to book. So cancel that reservation in progress, and that'll reset the session. So that is the unvalidated experience. What about applying a little bit more business logic and enabling us to do things like bound checking, ensure that our drivers are over 21 years of age, if that's our preferred bit of business logic, making sure that dates are in the future, validating that we've entered a city that is supported by the rental locations that we have. How do we go about doing that? And to answer that question, we need to know a little bit more about how Amazon Lex works under the covers, okay? And the main way that we work here is by exchanging documents, fixed format request documents, with other API endpoints within Amazon and within Amazon Web Services. And the specific service that we can use to apply business logic to our chatbot sessions is a service called AWS Lambda, which is a serverless execution environment for your custom code. So you can write code, deploy it within AWS Lambda, but then other AWS services can invoke that code or invoke those functions, okay? In this particular case, when we invoke our Lambda function, we're going to pass in a fixed format document that reflects the current state of the Lex chatbot session. What do we know? What slots are populated? What's the session ID? What's the conversational state? Are we eliciting a slot, or are we trying to fulfill this intent? And all of those pieces of state data are reflected within this JSON document that is passed to our AWS Lambda function on invocation. So if we understand the format of the document that we're getting, we can write code that evaluates and manipulates that document, makes decisions based on our business logic, and generates a response document that we can send back to Lex to drive the next part of the conversation. And that's what's happening under the covers once you wire in a Lambda function and connect it to your natural language interface in the form of your Lex chatbot. Okay, so we'll do that. We'll grab a Lambda function which is capable of enriching this sample chatbot with the business logic that we need. And to do that, we're going to open the AWS Lambda console in the same region in Ireland, which you'll see here. And we're going to create a function using a blueprint. Okay, and we can search our blueprints, and we want book trip was the name of the sample. Try that again. Lex. Here we are, book trip Python. So we'll deploy this, okay? This execution role grants the Lambda function the ability to write log data. So that's the only role that we're applying here. And that means that if we do need to debug our function, we'll be able to view our logging data from each execution in another AWS service called Amazon CloudWatch, which is our log consolidation service. So we need to grant permission for that, and that's what you can see within the console. And then this is the code that will get deployed into AWS Lambda and be invoked each time we get a dialog action from our Amazon Lex chatbot. Okay, so we've deployed that. Just takes a second. If we reload this console for Lex now, we should be able to pick up that new Lambda function in this region, and we can wire it in. We can wire that Lambda function into our chatbot, giving it permission to invoke, and we'll have the same thing for the fulfillment functionality as well. So we will save that intent with those changes, and we will build that new version of the bot. So what's happening now in the background is configuration changes will be reflected into the environment that we have. If we had done things like made changes to the language model by adding more representative intents or modified our slot configuration, those language models will be retrained, the classifier will be retrained, and those new slots would also be pushed out into the environment as well. So every time you make a change that you want to see reflected in your test environment, you need to do this build process to reconfigure and reestablish the environment with those changes. So there we go. If we try to rent another car, and we're renting in Lisbon, spell it properly, but you'll see the same thing. Lisbon is not a supported city. We don't provide the car rental service in the location that we previously specified. So we can go for a different one, maybe New York. Yes, we want to start yesterday. We can't rent yesterday. We must rent in advance. So you can see now that we've implemented a validation routine to make sure that we're entering data which is sensible, and also that we're able to guide the user towards data which is in bounds without, as I said earlier, having to add documentation. We've got a natural conversational flow which encourages the user towards values which are valid given this particular use case context. Okay, so that's a very simple example of enriching together with business logic, the front-end interface that handles the natural language processing component. And getting started is, well, it's really that simple with the sample chatbot. I'd encourage everybody to try that out. It's possible to do all of that inside the AWS free tier, so you won't see any costs on your bill for small-scale experimentation with this service. So that is a sample app. Let's talk about something that's a little bit more production-ready. Okay, and this is where we're getting into your responsibilities, things that you need to do in this session, which are interacting with this system. Okay, so travel around the world, give a lot of talks. Some talks are like this, where it's our event essentially within Web Summit. We know who's here. We will send you a survey after the event, which would graciously ask you to fill out for us with some data about our speakers and stuff, as well as the slides and your $200 AWS credit code. But not all events are like this, and often I'm out speaking at user groups and other events where I just don't have good user data capture. It's quite hard to get feedback to understand whether you've done a good job or not. And I wanted to build something that would help me solve that problem. That's exactly what I created. I created a Lexbot for interacting with customers that come to see me deliver sessions like this. And there's a few different things. So first of all, it enables you to rate or give feedback. So you can either give a score between 1 and 5, or you can provide free-form feedback, which we can analyze and figure out whether you're positively or negatively inclined about what you've seen. But you can also get information there. You can ask me questions like, what is your email? What is your GitHub? Are you on Twitter? And other things as well, and you'll receive information back. So it's an informational service, as well as supporting these two different transactions, rating and feedback, okay? And it's available in a couple of different ways. You can access it via Facebook Messenger. If you have Facebook Messenger, go to the People button at the bottom and scan code, roughly align your phone on that circular code, and you'll enter directly into a conversation with the chatbot. And you can say, I want to leave feedback, or I want to give a rating or leave a score, and you can engage directly in a transaction. Or you can ask me a question like, what is your GitHub, and see the source code for this demo, and another thing that I'm going to show you later. Or you can go here. This is a little bit more experimental, okay? This is a Vue.js sample app, a web app, which is connected to the same chatbot backend, but just runs in a browser, so you don't need Facebook Messenger for that. If you scan that QR code with a modern smartphone camera, you will be taken to the bit.ly link at the top, and you'll be able to immediately interact via a web application interface, which I'll just very quickly show you now, okay? Okay, so this is the app that you'll see on your smartphone. You can say things like, hello. And you'll get an informational prompt back there which gives some guidance on how to use the service. This is a requirement, by the way, if you're planning to deploy any chatbots onto Facebook's Messenger platform. They will ask you to have a help intent. And if you do not have a help intent, which guides users through usage of your application, your chatbot application, Facebook will reject you from application verification, okay? So it's a requirement on certain platforms that you have this. It's also activated with the help intent, which is the requirement. And then you can do things like are you on GitHub? But you can also conduct those two transactions that I've talked about. So you could say something here like Web Summit. It was today. We're in Lisbon. Or on Twitch. If you're on Twitch, you can say Twitch there. This is when I said a little bit more experimental. And then we're asked to rate the session between 1 and 5. I'll give myself a 5. And then I can say no and not cancel, and not submit that. But essentially what I can do here is interact with the system using the web interface to conduct these transactions, and also gain information about some resources that can help me build similar systems. So I'd ask if you wouldn't mind, either do that or use the feedback intent On the feedback intent, we're looking for free-form feedback. It was bad, it was good, I like your Skynet t-shirt, whatever you want, okay? A little bit of variation in the comments is good because you'll see a feature later on where we do some natural language analysis of what you write. But I really would like to encourage you to interact with that application using one of those channels. And that's really what makes the end of the session work. If you don't do that, this demo will be kind of flat. So please participate, okay? So what's behind the scenes? There's a few different AWS services behind the scenes here because I want to do more than just throw up an informational service where I respond to customers. I also want to gather some data and I want to visualize that data. So there's a pipeline behind this application that enables me to do that. When you submit your rating or submit your feedback, I'm going to capture that information into a JSON record, a JSON object. I'm going to ship that over to Amazon Kinesis, which is our reliable data ingest and streaming service. And that has another service associated with it called Firehose, which will enable me to persist those records in a variety of different targets, Elasticsearch, and also store them within Amazon S3 in raw format, just as a collection of records inside objects, inside files, so that I can analyze that data and provide some visualizations later. The other thing that I do on the sentiment side of things for those feedback scores is I call out to another AWS machine learning service, Amazon Comprehend, which is an NLP service, natural language processing service. And there I do sentiment analysis on the input. So if you say something nice, it will hopefully detect it positive. If you say something less nice, it will hopefully detect it neutral. And if you're mean, it will hopefully detect it as negative. And we'll show that in the visualization as well. And of late, I've been doing a few enhancements to this app. So on the S3 side of things, we have a new service called Athena, which is a serverless analytics and data visualization service. And I'm using that down here, as you can see, for analytics and visualization of the input data as well. So we'll show you a dashboard at the end that's built using this QuickSight service to get us that functionality. So just jump out of this, and I'll quickly show you the language models and some of the features within the Lex console that are relevant for this more advanced use case. Okay, and here you'll see that we have quite a few more intents. Let's make that a little bit larger. Okay, and the intents are a little bit varied. So we have the provide feedback and rate session intents, which are the core. Okay, and you'll see we've got quite a few sample utterances here to enable us to train a adaptable language model that is capable of picking up some variations in the way in which users turned out to interact with the service. Then we've got our slots, our session ID, our date, our city, and a number data type, which is our score from 1 to 5. And then we have our Lambda function for our back-end validation. So if you put in an invalid city or a score that's greater than 5 or lower than 1, you'll get a request to provide something which is valid. If you try to rate a session which is more than 30 days in the past, you'll be told that you can't, and obviously you can't rate sessions that are in the future. So there's some boundaries there that are set to help guide users towards valid inputs. Okay, so that's the transactional use case, and the same on feedback. Again, a diverse set of training utterances, plus a very similar capture, but we have our freeform session feedback slot type here. And this is a custom slot type, which is trained to recognize a variety of different sentence formats and resolve them down into the feedback slot. So we want natural language here. So once again, we're training our language model with sample data that enables us to resolve a variety of different sentence formats down into that particular slot. Okay? And then we have our informational intents, our help intent, where we just respond in fulfillment with, right now, I can take feedback on sessions, etc. My LinkedIn info, where we're going to respond with our LinkedIn information. Our cancel intent, this is quite interesting. So at any point, a user might decide that they want to exit the process. Okay? And this is an important nuance within Amazon Lex. Intent resolution is always active. So even if my current state is elicit a particular slot, ask the user what date the event was on, for example, the user might not do that. They might say, forget it, or I don't want to do this, or cancel, or goodbye, or end, or something else. if we have an intent which will resolve those things down, which just auto-fulfills, it allows for natural context switching. It allows the user to naturally break out of the workflow and return the bot to its initial state. Okay, so that's a bit of best practice that you might want to absorb. And it also, in this case, shows that you can generate responses in your back-end code, as well as generating responses using template responses here. As I showed you in the prior example, you can also programmatically generate responses using your back-end functions. Okay. Here you'll see more examples of responses that are generated directly within the console. You'll also see response randomization. So if you ask for my GitHub details, you'll get back one of these 3 responses in equal weighting. So you can have a natural experience where customers don't always receive exactly the same wording in response to the same request that they might make. It just makes it feel a little bit more like you're interacting with a real human. Okay? So that is the front end. And then in the back end, let's get this. In the back end, you'll see that I've got a Python code base here, which is my validation and fulfillment function, which is deployed again within AWS Lambda. And reading from the bottom up, you'll see that we have an intent resolver here. So the first thing that we do is resolve down the different intents. What is the currently active intent for the session? Okay, so for example, with provide feedback, they would pick that up from that fixed format document that we're receiving, and then we'll jump into the provide feedback function, which is here. And you can see that we have code here for validation. So we're looking at things like the date, we're looking at the value of the city field to establish whether or not these values represent valid values for this particular usage case. And if they don't, we'll reset those slot values to empty and return back to Lex with an elicit slot next step, where we will ask another question and try to move the conversation forward so we can collect the information that we need. If we do have a fully valid request, then we'll move on to fulfillment. And for fulfillment, you can see here that we put the contents of the JSON object that we construct into Amazon Kinesis, and that's ultimately how our data ends up persisted back in our S3 bucket or in our Elasticsearch cluster for visualization and analytics. On the cancel intent, which I mentioned as an example of generating responses, you'll see here that we're randomly selecting one of these options for the cancel intent, and we're returning that back to fulfill the intent with a random phrase selected from that list. Okay, so that's how you get your variation in the responses that come back if you say something like goodbye to the bot. Okay. On deployment over on Facebook, the way that you interact with this on Facebook is by integrating Amazon Lex together with the Facebook channel. Okay, and the Facebook channel is represented as a messaging API, which is supported within Facebook pages. Okay, so you create a Facebook page, where you create a Facebook application associated with that page. You request access to the page's messaging API. You go through a validation loop with Facebook where they vet your application and ensure that you have an appropriate privacy policy. Then they activate your app, okay? And we communicate with Facebook using exposed webhooks. Facebook provide a webhook, we provide a webhook within Amazon Lex. Those webhooks have mutual shared secrets for authentication, so we're signing requests that flow between them. When your Facebook page receives a message, Facebook hits our webhook with an authenticated request. We respond. We hit Facebook's webhook with the response, and that appears in Facebook Messenger. Okay? And we can test that as a page owner by clicking the test button option here and doing something like hi. And that process has just happened. So the Messages API, they've hit my webhook with the message hi with a session ID. We've generated a response back. We've hit their webhook with the same session ID, and that then pops the message up into Facebook Messenger, so you can deploy directly onto this platform. You can try a few of those random responses here as well. You'll see you're getting there you go. So you got randomized responses. These are the same. There's a 30% chance of that happening, of course. And then this is one of the other two options that's available to you. That's how you can build this kind of less repetitive, robotic language into your applications. Something else that we have here is testing. So this is another intent that I have created to show you a very useful feature on the Facebook platform, which is response cards. So here we can generate special format response documents that we send over to Facebook's endpoint using the webhook that they provide. Maybe we've hit a bug here. Try that again. Okay, yeah. So here we're getting a response card back. Okay, so the permissible options for this particular intent are restricted to 3 different strings, A, B, and C. Okay, very useful if you're doing something like asking a customer what size they want to order. Or maybe you've already got a city from them and they want to book a hotel. You could dynamically generate a list of properties in that city if you've only got 3, enabling them just to tap one of those options, because these on the mobile Facebook Messenger client are touch buttons. It's a really nice feature for mobile messaging. You don't have to type, just tap A, and it will auto-populate A into the field and send it back to the client. On here, we can actually click for the same effect. Okay. Now you see fulfilling that testing intent using test target A. So it's a really nice way to speed up the process if you've got restricted option sets that you want to provide. We also support card transcoding on Slack as well, so you can do the same thing with our Slack integration that you can do with Facebook. Okay, so there's 2 things left to show you. The first thing is, of course, the results. So at the back end of the analysis, we send the data into this service called Amazon QuickSight. And before this session, I'd received 284 scores so far this year, with an average of 5.8. With mostly positive reviews, 57 positive, a few negative reviews, in all these different locations around the world. Okay, so this talk's been done quite a bit. If I refresh this, what's happening now in the background is a series of SQL queries have been sent to our Athena endpoint. Okay, our Athena endpoint uses a DDL, a data description language, which maps the schema of the files that are being deposited inside that S3 bucket. And it will perform an SQL-style query across an array of data objects. Okay, so we don't have a table per se, we just have the objects scored. And you can see that our scores have gone up to 299, so 15 people provided a score, which is very kind of you. And my average has ticked up slightly to 4.59, so more positive than the average on balance. I can also introduce a filter here. So should see that we have data here for Lisbon. Okay, and I can introduce a filter on location, adding a filter condition for Lisbon only. And if I apply that to now rerunning the same query. Oh. Not work. Okay, maybe I can't spell Lisbon. Try this a different way, just a sec. Should be able to get the same effect. By doing this. OK, so we had 16 responses with an average of 4.75. We had 4 positive feedback scores, 1 neutral, 1 negative, and 1 mixed. You can actually see the session comments here as they're extracted out. And our negative was, "You are broken." So thank you. So you can see there that the pipeline works, and we're able to collect data in real time by using that very simple system. OK, so that's quite a good interactive demo, I think. For extra credit, I just want to show you one other thing, which is a kind of advanced topic. But you might recall that I showed you a custom slot, which was for feedback. OK, and in that case, I primed the custom slot with a variety of long-form English sentences or longer-form comments to train the language model to expect a variety of long-form English comments in that particular slot. There are, of course, other types of useful custom slot that you might want to consider creating for particular use cases, like a list of cities where you might have branches, a list of hotels, or a list of products, maybe if you're allowing people to get product information using this kind of system. Those data sets are likely to be programmatically generated and stored in other systems of record, right? So wouldn't it be helpful to be able to build automation to do slot training on a schedule? So say every Thursday you could figure out whether you've had any branches opened or closed and update your branch list dynamically with only the permissible values for that particular slot. Or how about postcodes? So a UK postcode example that I've got here. Now this is quite an interesting one because there are 2.58 million UK postcodes. As you can see here, 2.58 million unique UK postcodes, which you can download from the government. It's open data, OK? And the first thing that I did is I tried to train the model with 2.58 million postcodes. That didn't work too well. And my account got rate limited because I was trying to force too much data into the use case. It wasn't intended. It's not intended that you train a really wideband selection option with so much data. It's basically very, very far from optimal. So what I decided to do instead was sample the data. So I took 1,000 samples, and from that 1,000 samples, I construct a list, a Python list object containing key value pairs, where every key value pair contains the key value, non-unique keys, obviously, together with a postcode from this sample of 1,000. Okay, so I have a long list with 1,000 key value pairs in it. And then I can use the Lex client put slot type method on our API to fire that 1,000 postcode sample list into the slot and perform model retraining based on that extended list of postcodes, which gives me a really good basis upon which to resolve down other postcode samples that customers might input when giving address data. Okay? So the key takeaway here is you can programmatically manipulate these bots using AWS SDKs. In this particular example, I'm using the Python SDK inside a Jupyter Notebook, but you could quite easily build the same kind of thing into a data pipeline using Java or Scala together with Spark, or into your own custom web applications using our Node.js, Go, or .NET SDKs at the back end. You can manipulate the language models programmatically using this kind of tooling. OK, so that is pretty much all I have for you. I have 2 things left to say. First of all, thank you to the 25 or so of you that chose to interact with the demo. If you want to do so later, you can find my Facebook page, ian.massingham.aws, and have a play with the system later on. Don't forget that as long as we scan your badge, and this goes for people that are outside as well, if you're outside the theater, go and get a scan. We'll send you $200 of AWS credit that you can apply to your account. We'll also send you all of the material from the sessions this week. And I guess we'll also send you that digital follow-up survey as well, where we'd love you to provide some feedback on our speakers as well. So thank you very much.